Hi, welcome to my video on circles, that's inscribed, and central angles and arcs. This is video number 5. I have a circle drawn, and the circle has a center of O, and it says that the angle FOP is 80. Angle FOP is 80 degrees. So, I have find the measure of the arc FP. The arc FP, this is the arc FP, and the measure of the arc FP is 80 degrees because the central angle and the intercepted arc are the same measure. So this arc is 80 degrees. Now it says find the measure of FGP. Well, if we use a protractor, you can find a protractor. I'm going to measure those angles, and let's see. Let's start with FGP. The angle FGP, let's see what its measure is. We put it right along there and right at the center, and the angle moving up through here, moving up this way, is 40 degrees. While I have it here, let's measure the angle at L. And this angle is moving here 40 degrees. And let's measure this one. Put my protractor right at the vertex, and it's moving up here. So this angle PNF is 40 degrees. So they're all 40 degrees. So we have 40 degrees, 40 degrees, 40 degrees. So that's 40, 40, 40. So you notice also that the angle FGP is an inscribed angle because it's made up of two chords with a common vertex. And this inscribed angle, notice the angle FGP is cutting off the arc FP. And the angle FLP, this one has two chords with a common end. So this angle is cutting off the arc FP. Notice FLP is cutting off the arc FP, and that's 40. And there's another inscribed angle, FNP. This is the common end of the chords, so it's cutting off the arc FP. And so notice FNP is cutting off the arc FP, and that's 40. So these are all inscribed angles coming off this arc FP, which is 80, and notice it's a half. So the measure of the inscribed angles which intercept the same arc are equal. So all these inscribed angles off of this arc are half of 80 is 40, half of 80 is 40, half of this 80 is 40, but all these inscribed angles are equal. So the measure of the inscribed angles which intercept the same arc, and also is true if the intercept equal arcs, are equal. So let's continue. Let's prove that theorem. Let's prove the measure of the inscribed angle which intercept the same arc are equal. So using this diagram, let's prove that angle A equals angle B. And I'm going to use this diagram. And so we have that angle A is equal to a half of JK. So angle A is intercepting this arc, JL. I said JK, JL. And that's the inscribed angle is half the intercepted arc. So the inscribed angle is 1/2 intercepted arc. Number 2, angle B is half of this intercepted arc. So it's half of JL. and that's the same reason. So I just do ditto marks here. The inscribed angle is half the intercepted arc. So that's the same reason without taking all the time to write it out. And number 3, since number 1 statement has half of JL, number 2 statement has half of the arc JL, that means that angle A is equal to angle B, and the reason for that is called a transitive property of equality. Again, A and B are both equal to a half JL, therefore they're equal to each other. And below I have another diagram related to the same idea, and we have this diagram here. Notice we have no central angle, so it's given here that the measure of BVC, the angle, measure of the angle BVC, so this angle right here is 80 degrees, and the measure of the arc AD is 100. So the arc AD is here, so that arc is 100. So we have to find the measure of BDC. BDC, let's call BDCX. So we got to find the measure of this angle right here. So how are we going to do it? We got no central angles. Well, if this angle is 80 right here, and this is a straight angle, that means this angle right here is 100, because this is a straight angle adding up to 180 degrees. So 80 plus 100 is 180. Now we have a arc here that's 100 degrees. So this angle here is half of 100. So the inscribed angle is half the intercepted arc. And this angle here is in this triangle. So X is equal to 180, which is in the triangle, minus the 100, minus the 50. And so X comes out to be 30 degrees, which is BDC. So this angle is 30 degrees. Again, supplementary angle is 100. The inscribed angle is half the intercepted arc, and the angles of a triangle add up to 180. So all these properties we use over and over again when we're working them through. And we have another one to do. Again, we got a diagram. And as you can see, it's beginning to get more confusing. So you have to keep, because it's all angles everywhere, you have to look at the properties that you learned. Is there a center? No. Nowhere tells us that we have this center. It's not even labeled. So we have no center. That means we have no central angles. So let's see. Let's mark this in the diagram. It says the measure of the arc PT is 94. The arc PT is 94. PT is this arc right here. So this arc right here, this one, is 94 degrees. And it also says that the measure of the angle WAP is 71. So the measure of WAP. So this angle right here, and I'll mark it like this angle is 71 degrees. So I have to find the measure of the angle WPT. WPT. So I'm going to call that angle X. So let's call this angle X, just to instead of saying WPT all the time, we're going to get the measure of this angle right here, which is, just call it X. Now the reason I call it WPT at the beginning, because when you name 3 letters to an angle, great. When you name 1 letter, you got to be careful. So you wouldn't name this angle here with a T, because there's 3 angles at T. But if you had even here, there's many angles at this point. So to name an angle with 3 letters, WPT, I'm just going to call it X. So how do we go about getting the size of this angle? Well, we have right here, we have this angle is 94. So we have to get this angle is, it's subtended. See this arc? So what does PT? So let's look. So PA. So I'm tracing out this angle. So PAT is an inscribed angle. So that's 94. So this angle right here is 47 because this arc is PT. So if I can get an inscribed angle or a central angle, but there's an inscribed angle, PAT. So this angle is 47. Also, we have this angle, PWT. That angle is 47 because this is an inscribed angle cutting off, intercepting this arc. Now, since this angle here is 71, then 47 and 71 gives us a 24 when we subtract. The larger angle is 71, the smaller angle is 47. So this angle right here, WAT, so 24 and 47 is 71. So this angle is equal to X. Notice that WAT is an inscribed angle cutting off this arc, and WPT is an inscribed angle cutting off this arc. So that means X or WAP is 24. So, or you could say that this angle is 24, this arc is 48 because the inscribed angle is half the arc. So the arc is 48, then we can go back to here and say if this is 48, then this is 24. But there's a property we just did just then. The inscribed angles intercepting the same arc are equal. So these two angles are equal because they're both intercepting WT. Again, that's just another property that we learned or we practice. So try to do one property at a time and try to make more understanding, because now in a minute, a couple of videos time, it'll get very confusing. So you got to keep all these properties in your head. Again, if you like my video, click the like button. And you want to subscribe to my channel, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.